Alright, today let's have a look at topic 11, which are some fundamental concepts related to circles. Alright, first of all, let's have a look at some basic concepts related to a circle. So if we have a circle here, then any segment that connects 2 points on the circle is called a chord. And if a chord passes through the center of that circle, that chord is called a diameter of that circle. And half of the diameter is called radius. And if you have a line and there are two points of intersections of the line with the circle, then that line is called the secant line. Otherwise, if you only have one point of intersection between that line and the circle, then that line is called the tangent line of that circle. And the portion of a circle connecting 2 points on the circle's circumference is called an arc. And the area enclosed by an arc and the corresponding 2 radii is called a sector. And any area that is enclosed by a chord and corresponding arc is called a segment. Is clear? And of course, sometimes we also use the angle here. This angle here is called a central angle. Or if you see this arc here, then this angle here is also a central angle. A central angle of a circle is an angle with the center of the circle as its vertex. Of course, sometimes we use a central angle to help us to measure the length of an arc. The length of an arc, well, suppose this measurement is theta, then we could use theta over 360 degrees times the circumference of the whole circle, right? That's the length of arc. Of course, here theta must be in degree measurement if you use 360 as the denominator. Did you get it? So basically, we find the measure of an arc of a circle by considering what fractions of a circle of the arc is. For example, a whole circle is 360 degrees. So an arc that is 1/6 of the circle has to measure 60 degrees, right? So next we'll start with the length of the entire circle, which would be the perimeter of a circle. So basically, the perimeter of a circle is called the circle's circumference. And actually, the ratio between the circumference of a circle to its diameter is a constant. We call this constant as pi. So pi is a mathematical constant that is a ratio of a circle's circumference to its diameter, which is approximately equal to 3.14159. And pi is an irrational number. Which means that it cannot be expressed as a ratio of integers. Because pi is irrational, its decimal expression does not terminate and does not become periodic. In other words, it does not get to a point where the same set of numbers is repeated over and over. So there are no shortcuts to memorize digits of pi. So usually we use an approximation. Depends on which accuracy you need. For example, we usually take 3.14 as a approximation of the constant pi. So next, let's have a look at a practice. Okay, so basically this tells us that if you know the diameter then you could find the circumference of a circle, right? And vice versa. And now let's take a example question here. If the circumference of a circle is 32 pi, can you find circle's radius? So we know the ratio between the circumference to the diameter is pi, right? So in that case, if we let C be the circumference, and D be the diameter, we know that C over D gives us the constant number pi, right? That's the ratio between circumference to diameter. And of course, here we know the circumference, so D equals C over pi. In that case, C is 32 pi over pi, and this gives us 32, right? So the diameter is 32. Also, we know that the radius is half of the diameter. So if we let R be the radius, then we know 2R equals D. This gives us R equals half D, which is 16, right? So 16 is the radius of that circle. Did you get it? Okay, so in a summary, in a circle, if you let C be the circumference, D be the diameter, and R be the radius, we have this relationship here. C equals pi times D, which equals 2 pi R. Any questions? All right, then let's consider another question. If the length of a 72-degree arc of a circle is 15, what is the circumference of that circle? So in a circle, we have a arc that is 70 degrees here, and we know this length is 15. What is the circumference of that circle? Okay, so in order to facilitate our discussion, we could let the length of the arc be A, and let the let A be the length of the arc, let C be the circumference, of the circle. Then we have the following relationship. We know that the ratio between 72 degrees over 360 degrees is the ratio of the length of the arc over the circumference of the circle, right? These two ratios must be the same, right? And therefore we have 1 over 5 equals 15 over C, which gives us C equals 75, right? Did you get it? This is how you get the length of an arc if you know the central angle and the circumference of a circle, and vice versa, right? Any questions? Alright, then if you don't have any questions, let's consider another practice. Chord YZ of a circle with center O has length 12. The circumference of the circle is 24 pi. could you find the length of the arc YZ? Okay, we have a circle here. I'll suppose this is a point Z. There's another point Y. This is a chord YZ and corresponding arc YZ here. Could you find the length of arc YZ? And if you finish, please give me an answer in the chat box, okay? Oh, by the way, if you don't have a input for pi in the chat box, you could also use these two letters, pi. Okay, so let's have a look at the solution here. So to find the length of the arc, usually we must find the central angle here, right? We don't have any information about angles here, however, so we start by figuring out some length. Since the circumference C equals 24 pi, right? And diameter is phi over pi, which is 24. So we know the diameter is 24, and radius is half of the diameter, which is 12, right? So here r equals 12. The other side of the triangle is also 12, and we are also given that the third length here, the chord YZ, is also 12. So we know this angle here, YOZ, is 60 degrees, right? This is how we find the angle there. Therefore, we know the length of the arc YZ equals 60 degrees over 360 degrees times the circumference, which is 1/6 of 24 pi, which is 4 pi, right? And usually, if your result contains pi and the question does not ask you to use any approximation, you could just leave it there. Just use pi to denote the ratio between circumference and the diameter. You don't have to use any approximation if not required. Okay? Always keep your result in the exact form, which is 4 pi. Okay, any questions? Alright, if no questions, let's have a look at another question. Chords A, B, and CD of circle O has the same length. Can you prove that AB equals CD? So arc AB equals arc CD. So let's draw a circle. Okay, this is circle O. We have some point A, B, C, D. Okay, so give you that the chord AB equal the chord CD. Can you prove the corresponding length of the arc AB also equals CD? Okay, let's have a look at the solution together. So we form two triangles by connecting A, B, C, and D to O, right? And then we have triangle ABO and triangle CDO. Because we have AB equals CD according to the given information, AO equals CO, and also BO equals DO. Then we have triangle ABO must be congruent to triangle COD according to SSS congruence, right? Therefore, we have the two central angles are equal. Angle AOB equals angle COD, right? So if the two center angles are equal, then the corresponding arcs must be congruent. Which means length of AB equals the length of CD, right? Did you get it? Okay, so if you don't have any question here, consider if the reverse statement is also true. It seems like it's true, but you still need to prove that, right? So let's consider the reverse statement, which is if you have two equal arcs in a circle, can you prove that corresponding chords are equal? In that case, we have a circle here. If we know the two arcs, WX equals YZ, so this length equals this length here. Can you prove the corresponding chords are equal? Which means, can you prove WX equals YZ? Okay, have you finished? Not that difficult, right? We could say because arc WX equals arc YZ, then the two central angles are equal, which means angle WQX equals angle YQZ, right? And because we have WQ equals QX equals QZ equals QY, all of these sides are radi of the circle, so they have equal lengths. Therefore, we have triangle WQX, must be congruent to triangle YQZ by SAS congruence. So we have the corresponding sides of the two triangles are congruent, which means WX equals YZ, right? Did you get it? So in a summary, this tells us a very important property in a circle. probably want to write this down in a notebook. If two chords of a circle are congruent, then the arcs that they subtend or cut off are also congruent. Conversely, if two arcs of a circle are congruent, then the chords that they subtend them are also congruent. Okay, have we finished? Alright, let's use what we have learned so far to solve a practice question here. So I'll give you 3 minutes to consider this question by yourself, and then we'll have a look at the solution together, okay? Alright, then let's consider the second case where this angle here is 120 degrees, right? In that case, we connect A, B, and C to the center of the circle, of which the path is apart. Since we know more about the radius that we do about arcs, since arc AB is 120 degrees here, we know that C is the midpoint, so this point here is 60 degrees. This angle here is 60 degrees. This angle here is also 60 degrees, right? Therefore, OA equals OC equals OB. Therefore, we have triangle AOC and triangle BOC are both equilateral triangles, right? So we need to find the radius of the circle to finish the problem. So if we let AB meet CO at P here, since triangle AOP is congruent to triangle BOP by SAS, we have angle APO equals angle BPO. These angles together make up a straight angle. So if angle APO equals angle BPO equals 90 degrees, and then triangle APO and triangle BPO are just 30, 60, 90 triangles, right? Therefore, again, if you know one side of that triangle, you should find the other two sides. So in that case, AP equals half of AB equals 90. Then we have AO equals AP times 2 over square root 3. This gives us 60 square root 3, right? And we have AC plus CB equals AO plus BO. This gives us 120 square root 3. Then length, because of the central angle AOB is 120 degrees, so the length of AB, the length of arc AB is just 120 degrees over 360 degrees times the entire circumference, which is 2 times AO times pi, right? So this gives us 40 pi times square root 3. Therefore, the difference between arc AB with AC plus CB equals 40 pi square root 3 minus 120 square root 3. Did you get it? Okay, if you don't have any question, let's consider another question here. Triangle XYZ is a equilateral with side length 10. A circle is constructed with center X and radius 10, thus passing through Y and Z. Can you find the area of sector YZX of the circle? So let's draw a diagram for you to illustrate the question here. Suppose this is a point Y, this is a point Z, this is the center point X. Okay, let's have a look at the solution together. So our sector is shaded in the diagram here. So to find this area, you must determine what portion of the sector is of the whole circle, right? Since triangle XYZ is equilateral, we know that this angle here is 60 degrees, right? Since the whole circle is 360 degrees, this means that our sector is just 60 over 360 times the area of that circle. In that case, the area of that circle is pi r squared, and we know r here equals 10, right? So this gives us the area of that sector equals 1/6 times pi times 100, which is 50 pi over 3. You get it? You have any questions? So put this in a summary. This tells us that we can find the area of a sector of a circle of radius r given the central angle of that sector. In the figure to the right, angle AOB is the measurement of angle AOB in degrees over 360 degrees of the whole circle, right? Therefore, we have the area of the sector AOB is the ratio between the angle AOB in degree measurement over 360 degrees times pi r squared. Again, actually you shouldn't have to memorize this formula, right? This is pretty intuitive. Instead, understand that the area of a sector is simply related to the ratio of the sector's angle to the number of degrees in a whole circle, right? Any questions? Alright, if no questions, let's do a practice here. So farmer Tim has 50 feet of fence. He wants to enclose a semicircular area adjacent to his barn. Using his barn as one side of the enclosure, what is the area of the space farmer Tim can enclose? And once you finish, please give me your answer in the chat box, alright? So, well, you could draw a diagram to illustrate the situation. Suppose this is one side of his barn, and this is an enclosure, right? Which is a semicircular area. And total length of the fence is 50 feet. Okay, I'll give you 1 minute to solve this problem. And once you finish, please give me your answer in the chat box, okay? Alright, have you finished? So if you want to find the area, usually you need to find the radius of the semicircular area, right? So we could start from the sketch of the problem here. Our fence from a semicircular arc, so the arc has length 50. So let's suppose the radius of that circle is r. Basically, we have half of the circumference, which is 2 pi r, is 50. This gives us the length of r, right? Well, this gives us r equals 50 over pi. Then the area of the semicircular area is 1/2 of pi r squared, right? And that is 1/2 times pi times r squared, which is 2500 over pi squared, and eventually the area is 125 over pi. The unit should be square feet. Any questions? All right, great. So next, let's have a look at some more complex problems, but the method should be actually similar to what we have learned so far. So let's consider this question here. O is the center of the shown circle, and OA equals 8. The shaded region between chord AB and the circle is called a circular segment. Could you find the area of the circular segment here? Well, actually circular segment or segment is the difference between two areas, right? It's the difference between the sector AOB and triangle AOB, right? And again, once you finish, please give me your answer in the chat box.
Sorry, I think I put it like it's 16. Yeah, sorry.
Number, right? All right.
Yeah.
Let's have a look at the solution together. So basically, you're finding the difference between the sector AOB and triangle AOB. So the area of sector AOB is, we have 90 degrees over 360 degrees times pi r squared, right? So pi times r is 8 here. So this gives us 16 pi, right? And we have the area of triangle AOB equals 1/2 of bottom times the altitude, which is 32. Therefore, the area of segment AB equals 16 pi minus 32, right? You get it? All right, any questions? Okay, if not, well, sometimes our region isn't ready drawn for us, so we must draw the region by ourselves in order to solve that problem. For example, let's have a look at this example here. If I have a barn that is a regular hexagon as shown here on the right, each side of the barn is 100 feet long. I tether my burrow to point A with 150-foot rope. Can you find the area of the region in which my burrow can graze? So in that case, the region isn't ready drawn for you, right? You have to draw the region by yourself. You have to figure out what the region looks like. All right, let's have a look at the solution together. Again, as I said, first we need to figure out what region looks like first, right? Say the burrow is tethered at A, and roam so far that the rope pulls taut. Suppose the burrow keeps the rope taut and walks until part of the rope coincides with AB. The burrow then is at point G here, right? On the ray AB. Since AB is just 100 and the rope is 150 long, 50 feet long, right? 150 feet long, so BG equals 50 here. When the burrow moves beyond G towards C, then that's only 50 feet of rope for the burrow to use. And once the burrow moves past the G, the region he can reach is just the sector JBG, this small sector here, right? We have the same situation on the other side, so they are symmetrical in both sides, leading to sector HFI. Thus, our desired area is actually the area of major sector HAG plus the area of sector JBG plus the area of sector HFI. Actually, these two sectors are the same, so you only need to calculate once, right? Since angle ABC is 120 degrees, because ABCDF is just a regular hexagon, we have angle JBG equals, here, this angle is 60 degrees, right? Here. Therefore, sector JBJ, so we have area of sector JBG is 60 over 360 times pi r squared, right? Which is pi times 50 squared. And this gives us 1 to 50 over pi over 3. And the unit is square feet. On the other hand of the Gauss range is sector HFI, so that's basically the same, right? And finally, we have the sector between major arc GH and ready AG and AH. Since angle FAB is 120 degrees, then the other angle here must be 360 minus 120, right? Which is 240 degrees here. So the area of major sector HAG is 240 over 360 times pi r squared. In that case, r is 100 squared, which is you have oh sorry, this should be 150 squared, not 100. So eventually you have 15000 pi square feet here, right? And therefore the total area is 15,000 pi plus twice of this number here, right? This gives us 47500 pi over 3 square feet. Did you get it? So the key of this problem is to draw the area by yourself. If you identify the area you're looking for, things become much easier, right? All right, if you don't have any questions, you can also have a look at this question after this class. Let's have a look at another practice. So the shaded portion of the figure is called the loon. Given that AB equals 1, CD equals square root 2, and that segment AB and CD are diameters of the respective semicircles shown. Find the area of the loon. Okay, if you have any ideas, please give me an answer in the chat box, okay? Alright, let's have a look at the solution together. So we could start by noting that if we can find the area of this circular segment, then we could find the area of the loon, right? Because the area of the loon equals the area of the small semicircle subtracted by the area of the circular segment AB. Right? To get the area of the circular segment, we start by connecting its endpoints to the center O. Since the area of the circular segment AB, I'll just call it segment AB, okay? Equals the area of the sector AOB subtracted by the area of the triangle AOB, right? So we have the loon just equals the, well, if we put these two equations together, we have the area of the loon just equals the area of the small semicircle subtracted by the area of the sector AOB plus the area of triangle AOB. Okay, to find the area of sector AOB, we need angle AOB here, right? Since CD equals 2, we have OC equals OD equals OB equals OA equals square root 2 over 2. Seeing those square root 2s makes us think of 45, 45, 90 degrees triangles. So we check and see if that indeed the true. So we have AO squared plus BO squared equals 1/2 plus 1/2, which equals 1, which equals AB squared, right? So according to Pythagorean theorem, we know that angle AOB must equal 90 degrees, right? Then we can find the area of all our pieces. The radius of the small semicircle is 1/2. Therefore, we know the area of the small semicircle is just 1/2 of its area, which is 1/2 of pi r squared, which is oh, sorry, made a mistake here. This radius of that circle, the radius of that circle is 1/2, right? So that gives us ace pi. Okay, this one is solved. Then the area of sector AOB is 90 over 360 times pi r squared. And r is square root 2 over 2. And this gives us ace pi as well, right? Finally, the area of triangle AOB is half of AO times BO, which is 1 over 4. Therefore, we know the area of the loon equals ace pi minus ace pi plus 1/4, and eventually final result is 1/4. Did you get it? Okay, there is another question. Because of the time constraints, we could not finish. Please have a look at the solution. Have a look at the question here. Take a snapshot of that. We'll have a look at the solution in our next lesson. Okay, so there are a a bunch of questions you should have a look at after this class. So in our next lesson, probably we won't have any new lessons, but have a look at of all the homework questions there. Okay, so please do complete these questions after this class and submit your solutions in the Google Classroom at least one day before the deadline. All right, and please submit in one single PDF so I can mark them. All right. And okay, if you don't have any questions, class dismissed. I'll see you next time.
Thank you. Bye.